Hi there, Earth Science students. I wanted to take a little bit of time to go over our assignment here on determining latitude and longitude. You've been learning a lot about mapping the Earth and why that's important. And latitude and longitude are incredibly useful things to know when we're trying to figure out where in the world we are. And we still, even though we're using things like GPS instead of just maps that we have on paper these days, latitude and longitude are still very much used. And we talk about latitude and longitude in terms of degrees. For example, if we look at the Earth, the globe here, the one line that's running right through the middle, right, we call the what? The equator, right? And as we move north and as we move south from the equator, we have lines that circle the globe that tell us degrees of longitude or of latitude. Latitude. I think of latitude like a ladder. You climb up. So they run north-south. And those lines are divided up into degrees. For example, on my globe, every line is 20 degrees, right? But we have degrees from 0 to 10 and 10 to 20. We've got the Tropic of Cancer, for example, at the 23.5 degree mark. So we actually measure the degrees in whole numbers, so 1, like 31 to 32. But we also have ways, 31, by the way, to 32 degrees is a very large space on this globe. And so we even divide those degrees up into 60 equal parts called minutes, just like there's 60 minutes in an hour, for example. So we can really narrow in on a very precise point in the globe, right? So my lines go from the equator all the way up to the North Pole is 90, and that'd be 90 degrees north. And then all the way to the South Pole, and that'd be 90 degrees south. So those are my latitudes. And in between those teeny little tiny degrees, right, could be hundreds of miles, depending on where on the globe you are. And so even though you say 31 degrees north, you can break it down into more and more specific of an area by then talking about the minutes. So for example, 31 degrees, 10 minutes, and then 20 seconds, right? Because within each of those minutes are 60 more seconds, you can really zero in to precisely where on the globe you are. The same thing works for longitude. The longitude lines run this way. Instead of an equator, we have the line, the prime meridian, which runs kind of arbitrarily based on who was making these measurements right here. And then the lines go this way. And along with the degrees, again, 90 degrees east, 90 degrees west, there are also demarcations for minutes and then seconds. So you can get more and more specific till you pinpoint literally exactly where I'm standing right now. And that's what GPSs do with triangulation. Let's look at this assignment. The point of this assignment, and I've got my printed copy here, you should hopefully have yours open as well, is to help teach you a little bit about why we use the terms that we do, like how those are determined, the actual latitude and longitude, and then also to learn how to apply them practically to traveling, for example. The only tool you're going to need is your handout, and you don't have to print this if you don't have a printer. You can actually hold the protractor right up to the screen, right up here to my globe, either on your paper or on your screen in order to do this assignment. All right, let's take a look at question number 1, right? Question number 1 in part A, determining latitude. Hopefully you can see my screen here. Figure A represents, here's figure A, represents the Earth, right? And if you look at point B is going to be right along the equator. And we want to look at the line. In order to move a line from point B, right here, to point A in question number 2. So figure A represents Earth with point B at its center. Locate the equator on the globe. Where would I draw that equator? Right? So go ahead and do that now on your paper. Question number 2 asks you to draw the angle. If you draw a line from B to A, we can measure the angle. And the way that we're going to do that is with this protractor. So you can actually hold the protractor up to the screen, or right, you can print out your paper. Let me see if I can center this in my camera. Right, and actually hold this up to, with B being right in the center. Do you see where that B mark is? Hold my center right up to it and draw the line. So we're going to do this in questions 3 and 4 in with the different points, but the way that you use a protractor. For example, if I think about this protractor as part of the Earth, right? And here's my equator, 0 degrees latitude, and I were to draw a line straight up to the North Pole, right? What angle would I make? 90 degrees, right? Just like a right triangle. Can't be any more than 90 degrees, right? Goes right up here. And that's exactly where 90 degrees latitude north would be. Same thing if you drew the line going to the South Pole. 90 degrees, that is 90 degrees latitude in the South Pole. So when you draw the line, for example, if you make an angle like this, right, that would be 45 degrees. And where this point is right here, for example, it might be point C, for example, in this assignment, would be 45 degrees latitude. And so that's how we come up with those measurements. It's based on our understanding of the circle. And our world is more or less a circle. The globe is more or less a sphere. We'll talk a little bit more about that in our astronomy unit. So we might change our opinion on that a bit. But that's kind of how this latitude and longitude stuff works, right? If you notice, the latitude lines, they never touch. The equator runs all the way around. It's hugging the globe. And as you go up, same thing. Obviously, those lines, if these were lines of string, become shorter, right? Because you're going upwards on the surface. Whereas longitude actually touch at the poles. If you think about them running top to bottom, they actually come together. They converge on the top. All right, so for questions 1 through 5, we're looking at 1 through 4, we're actually drawing on this figure A, the different lines. And then if you have a globe, you can either use one that's online. There's a couple of online applications. Hopefully you have a globe. I have one in the lab if you want to use that. My globe, for example, has 20 degrees between each of the latitude and longitude lines. But some are more precise. They might have every 5. And some might have every 1, although that's a lot of lines to draw on a globe. So that's what question 5 is asking. On the example you're using, how far apart are those lines? Obviously, every single line doesn't really exist in the world. Like if I'm in my boat, I'm not going to cross the equator and see a line. But it is how we kind of break up space on Earth and figure out where we are precisely. Because think about this. If you know the latitude and you know the longitude, right? X marks the spot. You're going to figure out exactly where you are. Question number 6 asks you to look at figure B. So figure B, let's go to figure B. And I think it's asking for you to determine the latitude of each of these points. So let's look at figure B. Point E, where's point E? Right, 0 degrees. We don't say north or south because it's right in the middle, it's the equator. But what about point A? What about point A? Is this north or south of the equator? Point F gets a little tricky. It's not quite, it's in the middle of Africa somewhere. Right, actually right in the middle of the Sahara it looks like. It's between 30 and 15. So we're gonna have to estimate here. We're gonna have to estimate. Don't worry about minutes. We don't know precisely because we don't have that as accurate of a tool, but give me an idea somewhere between 15 and 30 where point F lies. So that's what we're doing for question 6. Now we're going to do the same exact thing as we do in question 6 for latitude. We're going to do the same thing for longitude, right, here in question 11, but with figure C. So here I only have my latitude lines drawn, and here I have only my longitudinal lines drawn. Now, if we were to place figure A over figure B with longitude and latitude, right, I could describe precisely where I was on the Earth. For example, point A at 30 degrees north, right, latitude, if I look on my globe and find 30 degrees north latitude, where are you 30 degrees? You're right there. Let's see what country it is. So we're right in parts of Algeria and Chad. But look, if I spin the world and follow that line, well, shoot, I can find 30 degrees running right through my hometown in Kansas, right south of Kansas City, between Kansas City. So it's only telling me this whole section of the hemisphere, the northern hemisphere, 30 degrees. Lots of countries share that location. So in order to be very precise, I also need to find the longitude. So that tells me not only is it going to be right up here, it's also going to be in a specific spot here. So for example, the town I grew up in, in southern Kansas. Wouldn't recommend growing up there. Where are you? There you are. Would be 40, 30, be about 35. Okay, I was wrong. About 35, 36 degrees north latitude, and then probably some minutes because that's a big section of Kansas. And then the longitude would be about, where's my longitude? Give me a number of longitude. 101 degrees, right? Maybe 101 degrees west. That's why we sometimes talk about like the Western Hemisphere. Well, we're in the Western Hemisphere, and we're also in the Northern Hemisphere because we're in the northern part of the globe, and we're in the western part of the globe based on latitude and longitude. Okay, so going back over these questions, let's see, did we answer them all? So questions 1 through 4, we're kind of looking at figure A and drawing lines. Figure 5, we're looking at our globe. Figure 6, we're looking at figure B. I'm sorry, question number 6, we're looking at B. And then on your globe or map for number 7, you're doing exactly what I did from my hometown, except you're doing it for Moscow, Russia. Now, you only have to list the latitudes. So you're going to be talking about degrees north or south, right? If we were talking about the longitude, right, we would do east or west. Using a globe or map in question number 8, name a city that's really far south of the equator as far as we are north of the equator. So for example, if we find Colorado and we know I think we're, somewhere between, based on the globe that I've got, it depends on how detailed it is, we're somewhere around 40 degrees north, then I want to find something that's 40 degrees south, right? So it's equally far south as we are north. Now, when we talk about climate and weather, we're going to find that there are some correlations, right? There's a lot of people that live in my hometown here, and if we go to a city that's equally far south, depending on factors like how close it is to the ocean, we're going to experience some similar weather. Okay, so I think you'll be able to figure out the, questions 1 through 12 based on what we've talked about. Questions 1 through 3 are really practical because in science, it's not just questions to answer in the back of your workbook, right? You need to be able to apply what you've learned. So question number 1 asks you, what's the maximum number of degrees latitude and longitude that you can have? Think about this. We can go up to 9 degrees here, but we can also go up to 9 degrees there. And then we also can go in either direction, east and west. And you're probably going to be able to relate this to what you know about circles and spheres. Number 2, longitude versus latitude. Longitude lines converge, latitudes don't. Explain. And number 3, pretty critical, poor Amelia Earhart. She's a big hero of mine. I've always admired her. Was lost. We think somewhere in the ocean, and we think somewhere in the Pacific Ocean based on her flight trajectory. We had an idea of where, but we didn't know why. And one of the theories is it's because the coordinates, right? We talk about latitude and longitude coordinates. Oh, give me your coordinates. And I can tell you, well, I'm 61 degrees south and 42 degrees east. And that's a really big area still. So then I can divide that up into smaller and smaller minutes to get the precise location. And if you're an island that's less than, I don't know, a kilometer across, you need to be pretty specific. So that's the assignment. Hopefully that makes sense. And email me if you have any other questions. And happy traveling.